So ocean creatures are not supposed to be driven to extinction because they are so abundant, they're so difficult to catch, there's all sorts of areas that they can get away from us, and so ocean life really, according to Lamarck, is highly resilient to extinction, and therefore we don't need to worry about it at all. Now, that may have been true at the beginning of the 18th century, but it's potentially no longer true. And if you look at a very recent review, which was published in Science this year, about the defaunation of the oceans, then this gives us a more sobering look at the state of marine biodiversity. And so here you can see over on the left-hand side a number of marine groups which come into contact with, rather intimately with us. They have terrestrial life stages, things like turtles, sea otters, and weasels, shorebirds, snakes and lizards that are marine related. And you can see that of the number of species in each of these groups, a large number have been assessed as endangered at some level according to the World Conservation Union's Red List of Threatened Species. Moving across to the exclusively aquatic realm, the picture is a little bit different. And one of the big differences is that we haven't assessed very many species that are wholly marine against IUCN Red List criteria. And so the state of knowledge of the status of species in the sea is really very fragmentary. And this is certainly true compared to species that live wholly on land. Among certain groups, though, we know that there are a significant number of endangered species, things like the cetaceans. This is the diadromous and brackish water fish species. These are the sharks and rays, and you can see that there's a large number of species that have been assessed as endangered, but there's still quite a lack of information. So let's dig down a little bit into what is causing species in the sea to become threatened. And if we go to this wonderful engraving by Albrecht Dürer and think of it in terms of the horsemen of the apocalypse. I think there are originally 4 horsemen of the apocalypse, but there have to be 6 horsemen of the apocalypse when it comes to extinction risk. The biggest and most obvious threat to species in the terrestrial realm is habitat loss and fragmentation, the destruction of species' living spaces. Close behind it, though, I think are introduced species. There are a whole raft of different examples of animals and plants that have been driven to extinction as a result of the introduction of new species into their ranges. And then we have plague and fishing and hunting, pollution, and of course, right now, as the principle says, climate change is very much looming into the future as being one of the major threats to species. So let me just run through a few of those and see what sort of problems are in the offing. Well, habitat loss in the oceans is happening, and it is happening very rapidly for some kinds of ecosystems. So here, for example, tropical mangrove forests, we've lost something like a third of them in the last 50 years, but in some countries, mangrove loss is verging on near complete, and there are now efforts to try and replant some of these mangroves, which have varying degrees of success because they're often being replanted as monocultures rather than the multi-species forests that were originally there. Seagrass beds as well. These are shallow water marine ecosystems, incredibly productive, and one estimate suggests something like a third of seagrass beds have been lost since the 19th century. These kinds of shallow water coastal habitats are really under threat for a whole range of reasons. There's habitat conversion to things like aquaculture, but there's also a process of coastal hardening which is taking place. And as the global sea level rises as a result of climate change, estimates suggest anything upwards of a meter of sea level rise by the end of the 21st century. The response is going to narrow the options for these kind of shallow water coastal habitats, and so they're under the gun. So there's a lot of habitat loss going on, but what are the likely consequences for species that inhabit them? Well, let's look into one group of species that one of my PhD students has looked into in great detail. That's not him. It might be, though. He graduated with his PhD last year, and he's the oldest graduate for a PhD in the University of York, ever. So 70 years old, which suggests that we haven't yet caught up with enrolling people in their 80s. But here we have cone snails. Cone snails are absolutely marvelous species. And what he did was to map the ranges of all 632 known species of cone snails. And this is what you can see on the top of those illustrations here. This shows the species richness of cone snails across the world oceans. And the richest part of the world is in this area, which is known as the Coral Triangle, this Indonesia, Philippines, Papua New Guinea region here. And indeed, the bullseye is right on the Philippines, which is where all that mangrove loss has been taking place. If you look at cone snails, though, there's not a single species that he assessed for the red list that meets the criteria for red listing that lives in that coral triangle. Despite the great concentration of species, none of them appear on the red list criteria. And the reason for that is that red listing is really about looking at species that are on their last gasp, things that have declined an enormous amount or potentially going to decline an enormous amount. And so they're missing the opportunity to identify species that are at high risk of loss. And if we can identify those species at high risk of loss, then we can potentially intervene earlier on and try and do something to avert extinctions before it's too late and we move into triage. So here in the middle, we have an approach to doing that. Here is an assessment of the degree of human threat and impact to coastal habitats around the world. And you can see that the threat level at the highest is highlighted in red. And what you can see there is there's a great concentration of threats in the areas where cone snails are at their richest. The other thing, though, that is important in identifying species at risk is that the smaller your geographic range is, the more likely you are to become endangered as a result of fairly localized human impacts. And so what we have down here on this slide, this part of the slide, is the concentration of geographically highly restricted rare species. And so you can see that there are certain areas where lots of species are popping up as being highly geographically restricted. And one of those, for example, is in the Cape Verde Islands over here off West Africa, where there's just an incredible hotspot of species found that are found nowhere else in the world. And there are some which are restricted, as far as we know, to a single bay in the Cape Verde Islands. So at risk are they. So here we have the kind of distribution of impacts. Now, if we put that together and look at the ranges of all the cone snails out there, what you see is that some species are exposed to very high levels of risk throughout their range. And so what this illustration shows is that 22 species of cone snail have all of their range within areas considered to be at very high risk of human impact and habitat loss. 34 species at high and very high levels. 126 species at medium, high, and very high. So you can see how this is working here. So there are some species of cone snail which are really in the crosshairs of human impact right now, and yet they're not showing up in the red listing process. If we expand the view a little bit, here you can see that the 56 species over here that are in areas entirely impacted to high and very high levels. But going down here, what you can see is that a large number of species have a large fraction of their range exposed to high levels of human impact. And so you can see that nearly a half of species have half or more of their range in areas exposed to very high and high levels of human impact. So the potential for extinctions is very significant as a result of habitat loss. So much for habitat loss. We can assume that it is going to be as problematic for species in the sea as it is for species on land as the wave of habitat loss gathers. So what about introduced species? Well, introduced species are always a bit of a wild card in any ecosystem, and predicting the outcome of a species introduction is very difficult. And that's because they can have all kinds of different effects. They can compete with species, for example. They can eat species. They can change the habitat. And these effects can be direct or indirect. So here's an example of a marine species that has actually been driven extinct altogether by an introduced species. So here's the devil incarnate when it comes to the California horned snail. What happened was that these things were introduced into the San Diego area, and they enjoyed it so much that they became incredibly abundant, as introduced species often do. They marginalized those horned snails and eventually caused their outright extinction in 1935. An extinction through habitat loss, but an indirect habitat loss, is the eelgrass limpet here, which went extinct in the 1930s on the eastern seaboard of the United States as a result of eelgrass wasting disease, which took out huge areas of eelgrass habitat. So the little eelgrass limpet lost its habitat as a consequence of this disease, and that may well have been an introduced disease. We don't know. Another potentially introduced disease which has had an incredibly large impact was one that affected the sea urchin, which is a keystone species in Caribbean coral reef environments, and was extraordinarily abundant all over the reef prior to a mass mortality event in the early 1980s, which started around the entrance to the Panama Canal and then swept through the entire Caribbean, down the South American coast, up the coast of the Carolinas, and took out the great majority of these Diadema antillarum. Now, for anybody who has trodden on a Diadema, this may not seem such a bad thing, but if you're a coral, it is a bad thing, because those Diadema kept algae short and coral settlement space in abundance. When they were gone, the algae overgrew the space for coral settlement, and so things have been going downhill since then. Another example of an incredibly potent invasion which is underway right now in the Caribbean is this one by the Indo-Pacific lionfish. Now, if you go to the Indo-Pacific and dive on a coral reef there, lionfish are not exceptionally abundant. In fact, they're quite scarce, and they spend a lot of time, it seems, hunting for food and not being terribly successful at it. Just successful enough to become a decent-sized fish after a number of years. But introduced into the Caribbean in the early 1990s, they have spread across the entire region, down the South American coast, through the Gulf of Mexico, out to Bermuda. They've gone deep down as well, so they're present from the surface right down to 300 meters or so. And in places like Bermuda, they grow to this size now. That is a heck of a big lionfish. And the reason that they do that is because they're gorging themselves on all these naive fish that are in the Caribbean that have never come across a lionfish before and have no kind of natural defense against it. So the typical kind of introduced species story, we don't know where this one's going to end up. It could end in extinctions. It certainly has ended already in the transformation of Caribbean reefs in a complete sense. They will never be the same again as when I first saw one. Now, hunting is something which has caused the loss of many species on land over very long time scales. And here's a bit of marine-related hunting with these sailors knocking some great auks on the head. And indeed, the great auk lost that match. It was rather unfair, given that it couldn't fly, and even great auks could be made to walk the plank into boats. So what the sailors would do would be to run a plank to a boat from the shore, and then they'd herd the great auks down the plank where they'd fall into the boat at the other end, and then they'd take them away and kill them. So great auks were one of those things which was almost doomed from the start for being too foolish to be able to persist in the face of human impact. But a number of other things have also disappeared as a result of hunting. And very unfortunately, museum curators were among the last people to kill a Caribbean monk seal. You know, this was the attitude back in the 1950s, is that, you know, monk seals are getting very rare. We need a specimen. Go and get one, please. And so dutifully, people were dispatched with guns and came back with a specimen, which may well have been one of the last Caribbean monk seals to be killed. So hunting has certainly been a problem for a number of species over the years. What about fishing? Fishing is the other great hunt in the oceans. Now, for those sitting at the back, I will spare you your eyesight and read this out. This is a description of fishing in the Shetland Islands from 1844, and it's fishing using long lines. So long lines are long lines, naturally, with hundreds of hooks on them. And here we have the quote. "Beginning at one end, the lines are drawn in. We were extremely successful. Almost every hook held a fish, small tusked, large, beautiful cod, skate, conger eels, saithe, or full-grown coalfish, but above all, halibut of various sizes, some of them gigantic, above 6 feet long. When these large fish or a powerful cod or skate appeared on the surface approaching the boat, the poor animal's struggles became frantic, and frequently we received showers of brine." So that gives you a sense that the sea in the early 19th century is not the sea that we find today around Scotland, and it has changed dramatically. And it is fishing that has changed that sea a great deal, and let me explain that. But first, a little dip back in time to one of our heroes, or anti-heroes if you like, in this story, Thomas Henry Huxley, who was Darwin's bulldog for his robust defense of the theory of evolution. But he was also a dabbler in fisheries. He visited here as part of a fisheries inquiry in the 19th century. And it was his view that we couldn't cause the extinction of marine species because of economics. And so the argument goes that as you deplete a fish species, then it will become harder and harder to catch, which means it costs more to catch, which means that we'll stop fishing for them, and therefore they'll be able to recover and everyone will be happy. Well, it hasn't quite happened that way. And one way that you can characterize the transformation that fishing has caused to marine environments is through this diagram of fishing down the food web. Now, when there's no fishing, natural ecosystems have large quantities of large animals, often predatory animals. The habitat structure is very complex and diverse, and so you have corals, you have seaweed forests, all sorts of things living on the seabed. And as you gradually intensify fishing, so we start seeing a thinning of those larger animals, and then a disappearance of those animals, and a transformation of seabed habitats. So they move from being complex and architecturally diverse with lots of species to being very simple. And so we get shifting sands and muds on the seabed where formerly there were invertebrate-generated biogenic habitats. And you could characterize this in space, as I've done here, but you can also do it in terms of time. So back there is then. That's the 1844 sea where people were fishing in the Shetland Islands, and this is now with the sort of fishery that we have off the west coast and to some degree off the east coast. When you look at species that have declined, those species tend to be large-bodied and to have a variety of vulnerable characteristics, very similar to the sorts of things that render species vulnerable to decline and extinction on land. So, this large body size, late maturity, long life, infrequent reproduction or episodic reproductive success, those sorts of things render species very vulnerable. Now, some of the species that have been disappearing, surprisingly, we really haven't noticed that they've been disappearing until very recently. So here, for example, sawfishes. A very recent review suggests that we've lost a huge number of sawfishes from areas that they once occupied. No sawfish species has yet gone extinct completely, but they've lost a vast amount of their range, and that, as we know, is always precedes extinction from taking place. So how could we miss something this enormous? Well, they live in muddy habitats, and many of them were caught long ago in huge abundance as bycatch in fisheries using gill nets or trawls, and so they've disappeared in the past. And we haven't really focused on these sorts of habitats either in our studies. And so suddenly we're waking up to this loss of sawfishes, which has happened under the noses of people in previous generations. And so the rarity of sawfishes today was considered to be normal, but it's actually very abnormal compared to their historical abundance. And within this country, we have many species that have greatly dropped in terms of abundance since those days in the early 19th century when eyewitnesses were out there enjoying a day's fishing with the locals. So here we have a wonderful set of stamps produced by the Post Office last year to illustrate sustainable and threatened species of fish. So these are the threatened ones, and there's quite a long list that we could have chosen to put on those stamps, but this was the list that they ended up with. The sustainable ones, if you want to eat fish, include things like Cornish sardine and dabs and pouting and so forth. But these are the ones that used to occur right up to the shoreline in places like St. Andrews, but you'd now be very hard-pressed to find some of these except in a few spatial refuges from fishing which have been out of reach of trawls. Now, these things declined a long time ago, like the sawfish, and coastal habitats have been hit hard a long time ago, but there are areas where that megafauna is disappearing right now. And here's one of the kind of last redoubt of some of the world's greatest megafauna, the high seas, areas beyond national jurisdiction. And this is where the frontier of fishing is taking place today. It's the least regulated part of the planet. There is very little in the way of effective regulation of fisheries which goes on in the high seas. That part of the regulation which there is, you don't have to sign up to. You know, if a country doesn't want to sign up to the international law of the sea, it doesn't have to. And if it doesn't, then it doesn't have to comply with the law of the sea's provisions. And so this is an opt-in law. And so, for somebody fishing with a flag of a country that hasn't signed up to it, it's perfectly legal to fish for anything you like in the high seas, which seems absolute madness. It's a bit like a burglar who robs your house and you can't prosecute them because they refuse to recognize the law against theft. This is what's going on in the high seas right now. And here is a method of fishing which is being used in the high seas to a very high degree, and that is longline fishing. The same method that was in use in the Shetland Islands back in the early 19th century, but this time using long lines that can be 100 kilometers long and carry thousands and thousands of hooks. And here's a study which looked at the at the catch and the bycatch on some long-line fishing off the coast of Central America, and 43,000 hooks set to catch 211 mahi-mahi. This is what else they caught. Hundreds of turtles, dozens of thresher sharks, green turtles even, silky sharks, pelagic stingrays, devil rays, hammerheads, oceanic whitetips, crocodile sharks, striped marlin, yellowfin tuna, blue marlin, wahoo, swordfish, and sunfish. So this is not selective fishing at all. This is the wholesale elimination of the ocean megafauna. And just to put it into context, what we're doing here is a bit like hunting for this wildebeest with a machine gun. Because, you know, there's one out there. There's your target species, a nice, fast-growing, highly fecund species on the African plain. But actually, you know, to catch it, you have to end up with lots of collateral damage. That is what fisheries are doing in many settings around the world. And that is what's causing the decline of these vulnerable species. Now, to go back to Huxley, you know, why are these species at risk? And the reason is that you can still make huge quantities of money as a fisherman from an ecosystem in this state versus an ecosystem in that state. So you can fish and hammer that ecosystem very hard, and the species that are left will cope more or less, and the species that can't cope will disappear. And so there's one of the paradoxes of modern fisheries, is that the most sustainable fisheries, and if you want to have a good conscience and say, yes, I only choose fish from sustainable fisheries, and therefore I'm going to go with you know, Marine Stewardship Council certified scallop fishery, for example, and eat with a clear conscience. The trouble is that these things come from highly destructive fisheries. And just to indicate exactly how that is, if you're not getting it, that is because those species have very high fecundity, they have a high rate of turnover, they can survive in highly modified environments, they can take a heck of a lot in the way of human-induced mortality and still thrive, just like these species can. And going lower, you can go lower than these prawn and scallop barrens that exist around much of our west coast now, for example, but you can't go much further. And here is an example of where people have gone further in terms of fishing. This is from the Gulf of Thailand, where they're essentially fishing for protein now, protein mush. It doesn't matter what shape or package that this protein is coming in. You just scrape it up off the seabed, you cook it up and boil it up and make it into pellets that feed prawns that then you can buy in the supermarket. And so therefore, you know, you're eating with a clear conscience again, because you haven't been eating wild-caught shrimp, which has a very high bycatch and destroys habitat, as I've just been talking about. Instead, though, you're destroying habitats to feed those farmed shrimp, which is one of the unfortunate consequences here. The trouble is that if we want to get back these species that we're losing, the ones that have declined so much, there's an obstacle in the way, and that is these highly productive fisheries for things like prawns are very valuable. And so there's a lot of resistance to it. And within the fishing industry, they will say, you know, it doesn't matter that we've converted this whole area of sea to these species because, you know, that's a good use of the sea, and it's highly productive, and therefore it's providing for human needs. So we shouldn't care. And I suppose if you took a terrestrial analogy, the equivalent would be to say it's fine to convert all of the rainforest from this into this, because this is highly productive, it meets human needs, etc., etc. But I don't think many of us would be very satisfied with that. And so we have to kind of counter that industry narrative that fishing everywhere, as we've been doing, is the right way to do things. I think that we have to do better if we're going to prevent species from going extinct outright. So moving to the last of the horsemen of the apocalypse, I'm going to wrap pollution and climate change together because naturally there's a lot to cover in a 1-hour lecture or a less than 1-hour lecture. So climate change and pollution. Now, one of the things that is happening in the sea, as surely as it's happening on land, is that the sea is warming. And in fact, it's because the sea is warming that we have been spared frying on land. It's absorbed huge quantities of the extra warmth that has been trapped on the planet since the Industrial Revolution took place. And so that's great, but it's warmed the oceans, and that's affecting a whole range of species. Now, this is the change in IUCN Red List status for a number of different taxonomic groups. You can see there's been a downgrading for amphibians, for example. Birds are more or less stayed level between these decades. It goes back to the 1980s and 90s. But corals have seen this massive slide. And the big thing that happened to cause that was a huge intensive warming event that spanned the whole of the tropics around the world. And in the Indian Ocean, 70 to 95% of corals were killed on coral reefs across huge areas of the Indian Ocean during the 1997 to 1998 bleaching event. Corals don't like extra warmth. The symbiosis that they have with the little microscopic algae breaks down when they get a little bit warmer than their comfort zone, and that causes mass death to take place. If that was all that we had to worry about in the sea, it would be enough. But there's another major consequence of pollution, which is associated with climate change, which has a very negative impact that lies mostly ahead of us right now. And that is that when you dissolve carbon dioxide in the sea, it makes the water more acidic. And as pH goes down, the amount of carbonate, which is dissolved in seawater, also goes down. And that causes trouble for anything that produces a chalky skeleton or shell. It's hard for us to predict what the effects are going to be on ocean life of acidifying it. And this change of an increase of 150% or so by the end of the 21st century is rather worrying. At the moment, what we have are a lot of experiments done in tanks in places probably like St. Andrews University. I don't know if anyone's working on ocean acidification at the Gatti Marine Lab, but people spike tanks with various levels of dissolved CO2 and see what happens. And these sorts of experiments tell us that they don't like it very much, organisms that calcify. What we can do is to look back in the geological record and see what happened during past episodes of ocean acidification. And it so happens that a lot of those were associated with mass extinction events. And so here we got the 5 big mass extinction events labeled in black at the top. What you can see is gaps in the growth of calcareous reef structures. And you can also see with these kind of brick-like patterns periods of prolific reef growth by whatever organisms were out there making calcium carbonate material and secreting that. So here we have periods when the oceans became acidic as a result of runaway climate change. And some of those we can home in on in some detail. So here, the end Permian episode of, the great extinction, 252 million years ago or so, wiping out something like 90% of all species and so on. And a lot of those species were marine, and the selective factor in this is that you were far more likely to go extinct if you had a poorly buffered calcium carbonate secretion mechanism. So things like corals, which have poorly buffered secretion of an external skeleton, they suffered really badly. Things like mollusks didn't suffer as badly. They're able to secrete calcium carbonate skeletons even under relatively adverse conditions of ocean pH. Now, if you look at the rate at which the oceans acidified after these events, here you can see at the end of the Permian, we were introducing something like 0.3 to 0.5 gigatons of carbon per year into the atmosphere here. Now, there's another event which is, has a lot of parallels for what's going on today at the end of the Paleocene, which is known as the Paleocene-Eocene thermal maximum. And here you've got probably a little bit higher rate of injection of carbon into the atmosphere, 0.6 gigatons of carbon per year over an extended period of 5,000 to 10,000 years. So here is a period of global warming which took the temperature of the Earth up about 6 degrees centigrade or so and caused ocean acidification. And not many species died, shall we say. But reef growth did suffer quite a bit. And then you contrast that with the rate of introduction of carbon into the Earth's atmosphere today. What we're doing today is way beyond what happened in these two mass extinction rates. So the rate at which we are pumping out greenhouse gases is in a completely different zone. So what we can take in terms of lessons from the past is a little bit limited. But one of the things that models show is that if you release carbon dioxide slowly into the atmosphere and therefore into the oceans, the impact on pH and carbonate concentration in the sea is far lower than if you release it very rapidly. And the effects are very long-lasting. So what we're doing today will give us a legacy that will last 10,000 to 100,000 years into the future. This is not something we can just reverse or future generations will be able to fix by some kind of technological change. It's beyond that. And what we release, we're committed to over the very long term. So what can we do in terms of all of these pressures and looming extinction problems? Well, the first thing that we have to do is to get to grips with climate change and greenhouse gas emissions, because if we don't, nothing else is going to save species in the sea. And so, you know, we've got to deal with that. But dealing with that's going to take time. We need to develop strategies for that. And so we've got to give species the space and the opportunity to survive through some very difficult times that lie ahead. Would you like some good news? Okay, well, the good news is that we haven't yet lost that many species in the sea outright. So here's the long history of human-generated faunal extinctions on land, going back to the colonization of Australia a long, long time ago. But the onset of global marine extinctions really can be traced back to the middle of the 18th century, with the loss of Stella's sea cow as a consequence of hunting and habitat change in the northern Bering Sea. And there are very few species that I'm aware of that have yet gone extinct outright in the sea. So most of the things that we're losing are still out there somewhere, which means that we still have the opportunity to save them. So that's the good news. The problem is that species are facing multiple jeopardy, and we're stressing them in all kinds of ways. And I've just given you some examples of how that's happening. So if we're going to improve their prospects, then what do we have to do? We have to reduce stress. We know that stressed people suffer from more illness and so on. And the same sort of thing is the case with marine ecosystems. We need to reduce the stresses, and we need to boost their ability. The immune system here might be seen as the population size of species. The more animals there are, the more plants there are, the more opportunity they have to survive and persist over the long term. So putting it in a simple way, what we have to do is to alleviate those stresses and ramp down fishing impacts, use less destructive ways to catch fish so we're not kind of completely transforming and destroying ecosystems in order to extract a handful of species. And we need to destroy less, obviously, and protect more. And the thing that I'm just going to focus on in the rest of this presentation is this: protect more and prepare for the worst, because time, as I say, is limited. Now, one of the problems that we have in averting marine extinctions is that we don't really know very much about the sea. And you might think that you know a huge amount about the sea, but of course, the problem is that the sea is enormous. And by various estimates, it's an enormous fraction of the biosphere. There are plenty of places on land that are only barely explored. Think about how that pans out in the ocean. There's a great deal of the ocean that we just haven't sampled, we've never been to, and that's especially so when you consider that the average depth is something like 4 kilometers or so. And if you want to know how much of the sea in the deep sea bed, that is, that we've actually been to or sampled with grabs, looked at from submersibles, it's an area about the size of Greater London. So that isn't much. I mean, if you were to zoom out to the planetary scale, you'd see just how poorly known the deep sea is. So we need some sort of strategy for capturing biodiversity and protecting it, which is going to be robust to a low amount of information on the species that are out there. And this is where we come to some work that I've just been doing with a postdoc at the moment on asking the question, how much of the sea should we protect if we want to avert extinctions and if we want to gain a number of other benefits from protection? So what we've done is to analyze 140 studies which address some aspect of this question. And these studies look at a variety of things. They're not just about extinction prevention, but they can include that, how much of the sea do we need to protect to represent all species in protected areas, to replicate them in different protected areas in order to ensure that they're not going to be wiped out by a single catastrophe. How much should we protect if we want to maximize fisheries yields? And there's a lot of research now on using protected areas to benefit adjoining fisheries too, which I won't go into, but it does mean that creating protected areas is not an altruistic act which comes at a sacrifice to fisheries. It can be integrated with fisheries goals to produce benefits for both biodiversity protection and fishing. And here is the outcome of this analysis. And so what you can see is the percentages that are recommended by these studies arrayed against the number of studies which recommend those percentages. And so the average percentage of the sea that is recommended to be protected to achieve or optimize or maximize benefits, depending on the questions, is something slightly over a third. If you're into medians, then it's almost identical. So here we have a result which kind of sets in context what we're doing right now. The amount of the sea which is protected in any form of marine protected area is about 3%. So we're looking at an order of magnitude more than that if we want to really safeguard life in the sea and the processes that life generates. Now, there are targets out there. 10% by 2020 is the big one from the Convention on Biological Diversity, and it's being adopted as part of the draft UN Sustainable Development Goals. But the World Parks Congress has opted for a more ambitious target of 30% of the sea by 2030. So here is something which is more aligned, as you can see, with the sort of evidence from the studies that we have out there. Now, I mentioned the high seas as being an area of intensive threat, but they're also an area of intensive opportunity. Now, if you think about the institutions that are failing to govern the high seas effectively, there's no likelihood that they're going to improve their game in the near future. And the amount of fish that we're catching on the high seas is trivial anyway. It's something like 5% of the total global catch. Under these circumstances, with that tragic loss of ocean megafauna, wouldn't it make sense to call a pause to high seas fishing? And these two authors have looked at it from an economic perspective, and what they've concluded is that actually if we closed all of the high seas to fishing, there could be an economic benefit, because many of these species that we catch on the high seas can actually also be caught in the exclusive economic zones of various countries under much better regulation. And so rather than having this free-for-all out on the high seas, it would be better to have more highly regulated fisheries within countries' exclusive economic zones. And the loss would be minimal. In fact, the likelihood under most of their scenarios is for a strong economic benefit from doing this, because the state of these stocks would improve. And a follow-up analysis that a group of us have done looks at how the distribution of winners and losers pans out across the world under various scenarios. And if we close the high seas, then under a modest scenario of exchange between national waters and international waters, the great majority of countries will actually win. They'll get more, and there will be far greater equity in who is benefiting from the catch, because instead of a handful of countries going out and fishing on the high seas and over-exploiting and causing decline, far more countries would be able to benefit from catches within their own waters. Now, E.O. Wilson has recently been proposing that we should set aside half of the Earth for wildlife and species. Now, if we protected all of the high seas, we get a long way there. 42% of the Earth is high seas, just to give you a sense of their size. But obviously, that's all in one habitat, and that wouldn't be good enough to protect the whole variety of species. But in terms of the benefits that these studies show from protection, if we look at the half-Earth solution for the seas, that would yield something like 80% of all the benefits that these studies looked at. And it would be a very good strategy, I think, in the oceans. So this is even greater than the kind of 30% or more protection of the seas. Now, just going back to this fishing down the food web diagram for a moment, to look at, it's all very well to have protected areas, but what should we protect them from? And what this implies is two things. One is that losses happen quickly and they happen early on, and the big and vulnerable get knocked out first. And so that's one of the things that fishing has done, and it has an implication for protection. And that implication is that if we want to bring those things back, then we will need to protect places very highly. And so you have to move this arrow of protection a long way before you start seeing real pickup in terms of the benefits to these vulnerable species that are disappearing. And it's really the last bit, the last drive, that will get back those species. And so very high levels of protection are necessary for the sort of comeback and protection of these species that we're losing. Now, how are we doing with MPAs? Well, Scotland has a strategy for MPAs, and that strategy is to create a national network of marine protected areas. So far, so good. Here they are in yellow, and the proposals for the management of them are out. Now, let's just home in on the proposals for one of those areas. It's representative, though, in terms of these other areas that are on the table. This is the South Arran MPA. And here you can see the areas that are left open to bottom trawling and scallop dredging, the two most destructive forms of fishing, the two that are responsible for the great majority of this transformation of the sea from lots of big stuff to lots of tiny things, and from habitats that are complex to habitats that are very simple. And so the idea that these are protected areas, if they're left open to the great majority of their area to these destructive methods, is quite frankly absurd. And the Marine Scotland really haven't got it together in terms of what is necessary to safeguard life in the sea. And sadly, Marine Scotland are not alone. I'm afraid that Natural England and the Joint Nature Conservation Committee are just as bad in the English network. The Welsh are busy struggling too. So this is something which is countrywide. So what's going wrong? I think one thing that's going wrong is that people are ignoring the past. And so there is no ambition in this network of protected areas to bring back these huge fish that used to be nearly jumping out of the ocean right onto the beaches because we've simply forgot about their existence. And if they happen to be in one or two places that are natural refuges, well, fine. There's no ambition to bring them back. There's no ambition for a real restoration of these animals. And as a scientist, let me just do a quick experiment. I got my tape measure here. This is a common skate here, and we'll just show that common skate in relation to the size of this lady, girl, whatever. She's probably only this size, but you know, it's a huge fish. Those huge fish won't come back without very high levels of protection, and they won't come back in places that are left open to trawling and dredging. The other thing that I think that is missing here is the view that we should be doing conservation in the sea in the same way that we're doing it on land. And on land, what we do is often characterized as wildlife gardening. You know, you can see there's a little clump of trees there. We can go and protect them. We can look after them, you know, make sure that they're all very happy and so on. In the sea, we can't do that. We can't piecemeal down to small areas of habitat and say, you can have this kind of management, you can have that kind of management, and everything will be able to persist as it should be. In fact, the sea is wild, and we've got to give that wildness the space to express itself. We've got to provide the conditions for the comeback, not try and micromanage that comeback. So in closing, I just want to reflect on what happens when you don't provide the protection that is needed. And this is the sad case of the vaquita in the Gulf of California. It's only found in the upper Gulf of California in Mexico. And it's been known to be highly vulnerable to extinction for decades now. And those early studies on it were quite clear about what was causing their death. It's the gill nets from fisheries for totoaba, for example, huge cyanid fish which lives up in the northern Gulf. And you could see this rare species being depleted by dozens of animals every year. And now the last tragic survey has suggested that there's under 100 left. And still the Mexican government is not doing what is necessary to protect this species, which is to get rid of all the fishing. If you want to have this animal, if you want to protect it, if you want it for future generations, there is no choice in the matter. You've got to close that fishery down, because otherwise extinction is a certainty. And I worry that the same sort of vacillation is happening in the case of an animal like the leatherback turtle. This is a creature that has an evolutionary history which goes back 100 million years. But in the Pacific Ocean, it has declined by something like 96% in just 20 to 25 years. And this is a result of long-line fishing. They get entangled and they drown. And really the only thing that's going to save the leatherback turtle is if we get to grips with providing refuges from that impact, which are very significant. I'm not entirely pessimistic. You know, 100 animals suggest that the vaquita is toast. But there is a precedent for optimism, and that is the northern elephant seal, which itself went down to about 100 animals at its nadir. And it has come back wonderfully and dramatically with the right kind of protection. So finally, preparing for the worst. And that means putting protected areas that are very significant in size and in their high level of protection and ambition in the places that are least impacted by people, in the hope that they will provide refuges into the future that will safeguard species through these tough times ahead. And some of these kind of very large-scale protected areas that are being created across the world are in very remote places. So here, for example, Motu Matiro Hiva in the southeastern Pacific is a very isolated patch of Chilean real estate near to Easter Island. There are proposals to protect Easter Island as well. And I am very glad to say that the British government, the present government, has tucked away at the back of the budget speech, there's a little paragraph that says, We will establish a marine protected area in Pitcairn, Ducie, Henderson and Orano, which is going to be the largest fully protected marine reserve in the world. And so this is a commitment which the Conservative government has made. There are others on the table, for example, in Ascension Island and South Georgia and South Sandwich Islands, which may pan out under future governments. But it is something which has cross-party support, so please don't let it affect your voting in the forthcoming elections, although I don't think the SNP has said anything about how they would look upon protection of the overseas territories. But this is the kind of thing, this is the kind of bold statement which is needed if we're to save species in the sea for future generations. Thank you very much.